Let me to start 37, question number 37. A particle of charge plus Q and mass M is moving along a positive x direction in a vacuum where the electric field is zero. Electric field is zero. This particle then enter x equals 0, a uniform electric field of intensity E extended over a large region. Extended over a large region with the velocity v as shown in the diagram, as shown in the figure number 1. The electric field is direct along the negative x direction. Describe qualitatively the motion of the particle after entering the electric field. Neglect the effect of gravity. Right, let me to explain this part. So that's the electric field. Electric field, look at the direction. A positively charged particle is released at a certain velocity at this point, plus q charge. When it comes to, there is no any field from here to there. This is x direction, positive x direction. X direction, x equal 0, just like origin. So this one object started at this point with the same velocity, positively charged particle. What happened at this point? It looks like in this side you have a positive plate. Positive plate. So there is a force. It's a repulsive force for this charge plus q. It's a repulsive force F. It's a F repulsive force. It travels with the retardation. Look at it. It initially traveled towards the right hand direction, but now the resistive force is opposite to that direction. So it travels with the retardation minus acceleration is there. At a certain instant, it comes to a momentary rest, turn back, and travel along the same path with an acceleration. That could happen. That could happen. That is what that is what happened inside this system. It travel with a certain velocity, enter with the same velocity, but when it enter the same velocity, enter the system, it looks like the positive plate is placed in front of it. So what happened? The repulsive force would generate. Because of that, it traveled with the retardation. At a certain instant, it comes to a momentary rest. After that, turn back and travel with the same acceleration opposite to the previous direction. That's what you want to write qualitatively. That's what mean by qualitative writing. Anything to ask, any one of you? Anything to ask? Okay, just write under that. Particle experience, a deceleration, stop, particle experience a deceleration, stop at a certain distance, comma, starts to move back starts to move back along the same path, with an acceleration whose magnitude equal to that of the deceleration, and leaves the electric field with the speed v. So remember that sort of thing. Started with a certain velocity, same velocity maintained up to that, travel the retardation, momentary rest, turn back, and travel with an acceleration. Same acceleration in terms of magnitude, retardation magnitude, and the acceleration magnitude are the same because the same force is applied always. ඒක නිසා retardation එකේ magnitude එකත් acceleration එකේ magnitude එකත් same. ඒක නිසාම මෙතනින් එළියට යන්නේ velocity එක වීම තමයි, speed එක වීමයි. ඒක මතක තියෙන්න ඕන. Anyone want me to explain more? Anything to ask? Right, clear ne? Okay ne? Right. Next point. Two particles P and Q, each of charge plus Q and mass M, start to move at a time t equals 0 in a vacuum simultaneously with the two initial velocities v1 and v2 respectively. They have given you v1 greater than v2. If you want, you can draw that lamaya. Mekwa and that hondai man hitanne minus a plus a in that direction, the same velocity as v. මෙතනින් v යනවා, මෙතනින් v යනවා. minus a plus a. arrowheads හරියට දාන්න. Right, done. Shall I start? Okay. Right. Two particles. I will erase this now. The two particles P and Q, each of charge plus Q. This is P and this is Q. P and Q. start to move at a time t equals 0 in a vacuum simultaneously with the two initial velocities v1 and v2 respectively, given that v1 is greater than v2. This is v1 and this is v2. v1 is more than v2 or greater than v2. This is given as L and this is given as H according to the question. At x equals 0, t equals 0, it release. T equals 0, it release. This is a vacuum from x equals 0 to x equal L. It's a vacuum, no gravity, no electrostatic force, nothing. හැබැයි මෙතනින් එහාට electric field එකක් create වෙනවා මෙන්න මේ පැත්තට capital E කියලා. There's an electric field from this region to that region. So I can mark it like this. There's an electric field from this region to that region. If the two particles travel in a field free region from x equals 0 to x equal L here to there, obtain an expression for the separation D between the two particles at the instant when the faster particle reach x equal L. Since v1 is greater than v2, this particle would reach the x equal L first. Let's say that time is t1. මෙතන ඉඳලා මෙතනට යනකොට time එක අපි හිතමු t1 කියලා. t equal t1. But remember, this particle having the velocity less than that velocity, so definitely it can't reach to this location. It is reached within the same time frame. It can reach up to this level. Let's say the distance is s1. Actually it is capital L. S1 is capital L. S2 is, we have to calculate what they want, the separation. Obtain an expression for the separation between the two particles at the instant when the fast particle reach x equal L. They want us to calculate a certain value for the D, which is exactly equal to S1 minus S2 or else L minus S2. D. This is what they want from us. Okay, for the part A. So how to do this? So first we can find the velocity, we can find the time duration. Without any problem, we can apply S equal ut for this charge. S equal ut. S equal ut. This is for P. බලන්න අපි හැමදේම පිළිවෙලට ලියන්න ඕනේ. S equal ut for P. There is no acceleration from here to there, so no need to write anything. S equal, it is L, initial velocity v1, the time is t1. So t1 equal L divided by v1. L divided by v1. So what is the value of S2? For Q then, S2, S equal ut, then v2 into t1. v2 t1 L divided by v1, S2. Just substitute there. Let's say number 1. From number 1, D equal L minus V2 L divided by V1. L1 minus V2 divided by V1. This is the answer. 1 minus V2 divided by V1. 1 minus V2 divided by V1 is the answer. Anything to ask? ඔයාලට මොනවද තියනවද අහන්න? How about the others? Others are okay. Right. So the separation we got. Let us start the second part, part B, in our question, part B. At x equal L, the two particles enter uniform electric field of intensity E direct along the negative x direction. This is positive x direction. Negative x means this. Positive x means this. Negative x means this. So this is the direction of the electric field. Negative x direction. If the electric field is extended from x equal L to x equal L plus H. L from L to L plus H. As shown in the figure, obtain an expression for the minimum value Em of the intensity of the electric field required to turn both particles back and make them travel in the negative x direction. Negative x direction. Right. Okay. What is mean by this? So when this particle P enter to this region, is it travel with an acceleration? Is it travel with the acceleration? Tell me the answer for this. Is it travel with an acceleration? When the particle P enter to that region, I mean electrostatic field, will it travel with an acceleration? It travel with what? It travel with a retardation, deceleration. How about Q? If the particle Q enter to this region, will it travel with an acceleration? Will it travel with an acceleration or the retardation? A retardation. Yes, both particles must have a retardation. Retardation. If you consider this particular concept properly, V1 is greater than V2. Do we need to which particle is much complicated for us to stop at a certain distance? Which particle we feel much complicated to stop at a particular distance? What do you think? Which particle? Which particle you feel difficult to stop? Because we know that how the motion is takes place. මෙතන ඉඳලා මෙහෙම ගියා, momentum rest එකට ආවා, ආයෙ turn back and travel with an acceleration. That would happen. Out of that, which particle we feel to stop at a certain distance? Difficult to stop at a certain distance. Compare with P and Q. So how about the other students? අනිත් අයගේ අදහස මොකක්ද? Which particle difficult for us to stop? So one object is traveling with 200 meters per second. Other one, identical object, it travel with 100 meters per second. Which one we feel easy to stop? So ළමයි, I need your answers. ඔයාලා මේ question එක තේරුම් ගන්නවා කියන එක දැනගන්නේ මම ඒවයි. So I need your answers. Particle P takes more time to stop. I will explain this part like this. Let's say we have two particles, P and Q. P 50 ms minus 1, P 50 ms minus 1, and Q it is 20 ms minus 1. So you are applying the same force because the charges are the same for both P and Q. So you are applying the same resistive force, same opposing force. So for this particle, if it travel with a certain distance, this one travel less than that distance. Am I correct? So now the final velocity is 0. The final velocity is 0. Am I correct? How about the other students? Others are okay? ඔයාලගේ attention එක දෙන්න ඕනේ question එකට. නැත්නම් මේ question එක සෑහෙන වෙලාවක් අරගෙන අපි explain කරනවා question එකක්. එතකොට ඔයාලට ඒකේ වටිනාකම තේරෙන්න ඕනේ. මම මේ කියන දේවල් ඔයාලට වැදගත් වෙනවා වෙන question එකක් හිතනකොට. ඒක නිසායි question අහන්න නැතුව I don't want to pressurize you guys. I don't want to pressurize you. හැබැයි මට ඕනේ ඔයාලා මේක තේරුම් ගන්න එක. මම මේක 50 වලින් යවලා මේක 20 වලින් යවලා එකම forces same forces apply in those two objects. This one stop with a certain maximum distance compared with that. Okay, obvious ne? Clear ne? This question the way that they ask, obtain an expression for the minimum value of En. Right. If you let's say this is the last point. This is the last point. I'm applying like 20 Newton per coulomb electric field towards that direction. This is the last point which is taken as L plus H point. L plus H. This is according to that it is L. This is the last point. Okay. I can definitely take this particle P momentum to rest at this point. If I increase this 20, what happened to this particle? Will it jump L plus H point or will it stop before that? What is your answer? So I can answer your question. I can give the answer, but I want you to understand how, I want you to analyze the question. If you increase more than 20, may particle like a 20 වලදී just an example හරි 20 වලදී මෙතන නවතිනවා 20 වලදී මෙතන නවතිනවා Q. මොකද ඒක ගැටලුවක් නෑ 20 මෙයාගේ 50 ms minus 1 20 ms minus 1 high velocity means මෙතන එනකන් යන්න පුළුවන්. හැබැයි මෙයා 20 වලට වඩා වැඩි කරොත් let's say now 30 වුණොත් මේ particle එක P මෙච්චර දුරක් එනවද මෙතන මග නවතිනවද සහ will it go beyond this particular plane මෙතනින් එහාට පයින්නවා jump කරනවද කියලා යහන්නේ. Yes, I think almost all the students got the idea. It is stopped at this point. At this point, it never come to that location. And the meantime, if I increase further like 30 or 50, it stop at this point. I think my point is clear. If you drop 20 by 10, initially when it comes to 20, it was there, it was here. If you drop by 10, what will happen? What will happen? Will it jump from L plus H or stop in front of L plus H? Definitely it will jump. It will definitely jump. So can you tell me the minimum value of the electric field intensity according to my example, which I need to apply, so that it will return back to the again the other direction? Yes, I think the answer is there. 20, ne? 20. It is 20, not 10 or 30. It is 20. I should apply 20 so that 50 ms minus 1 come to this point, momentary rest, turn back and travel along the same direction. Make a කොහොමත් මෙතෙන්ට වගේ ඇවිල්ලා එයා අනිත් පැත්තට යන්න. So I think you can understand what I mean by minimum electrostatic field intensity. That is important part to understand. It is minimum electrostatic field intensity. Now we will come to the question again. At x equal L, the two particles enter uniform electric field of intensity E direct along the negative x direction if the electric field is extended from x equal L to x plus h. Obtain the expression of the minimum value of En. Minimum value of Em of the intensity of the electric field intensity required to turn both particles back and make them travel in the negative x direction. So do we need to worry about this? No, we don't want to worry about that. We want to worry about only the P. Right? Particle P enter to this location with the same velocity v1. Now it is rest. It is momentary rest. The final velocity becomes 0. Location, I have taken the location as initial. I have taken the location. No, I can use that. May particle එක ගත්තොත් මේ වගේ දැනකට ඇවිල්ලා ආපහු turn back. This is what important is. Right? Okay. Since the particle P velocity is greater than, you can write like this, greater than that of Q. Since the particle P velocity is greater than that of Q, it is much important. It is much important. Therefore, we can apply our equation. We know that it started from here and it come to this point. We can apply V equals V squared equal U squared plus 2AS for P. For P, V squared equal U squared plus 2AS, 0, V squared, 2, retardation is there, A, X. It is actually H, 2AH, 2AH. But what is V1 squared equal to AH? මෙන්න මෙතනින් තමයි අපි ගන්න අර acceleration එකට ඕන equation එක. Let's say number 3. F equal ma. F equal ma towards that direction. When you apply F equal ma, we can apply in the other direction. F equal, it is E minimum. E minimum. Now we get E minimum. E minimum into the charge. What is the value of the charge? What's the value of the charge? It is plus Q. Mass into acceleration. A equal Em into Q divided by N. Just substitute. V1 squared equal to HAEM Q divided by simple M. So the EM equal, you can't see that. I'm trying to use this space. EM equal the minimum velocity, minimum electrostatic field intensity, M V1 squared divided by 2H into Q. 2H into Q. It is the minimum electric field intensity. Can you write up to this level? Now consider a situation when E is greater than that of En. Now it is greater than that of En. What will happen? Now you have an idea. මොකක්ද වෙන්නේ? EM ට වඩා වැඩි ඉලෙක්ට්‍රික් ෆීල්ඩ් එකක් ආව ගමන්ම මොකක්ද වෙන්නේ? P කියන පාටිකල් එක අර කියන මාජින් එකට ඉස්සරහා නවතිනවා. Right? It stop before L plus H distance. X equal 0, X equal L, X equal L plus H. This is P and this is Q. V1, V2. V1 and V2. Right. So now the electric field is applied, capital E. Capital E is given as more than En. Capital E is more than En. So now tell me whether the P particle would come to the last point or is it stop before that? Will it come to the last point or will it stop before that? Stop before that, right? Everyone is agree with that. I think everyone is okay with that. Yeah, මෙන්න මේ වගේ තැනක නතර වේවි. නතර වෙලා acceleration එකෙන් අනිත් පැත්තට යනවා. මෙයා මෙන්න මේ වගේ තැනක නතර වේවි. We don't know. But anyway, we know that it is more than less than that. Obtain expression for the times Tp and Tq spent by the particle P and Q respectively in the electric field. Now it is entered to the electric field. Entered to the electric field with the velocity of V1. It is entered to the electric field with the velocity of V2. Started with the time measurement here. Take the time, come to this point. The total time is now Tp. If I take T equals 0 at this point, now it is T equal Tp divided by 2. You all agree with that? It is T equals 0. මෙතනට ගිහිල්ලා මෙතනට momentary rest එකට ගිහිල්ලා මේ පැත්තට මේක pass වෙනකොට time එක තමයි අපෙන් ගහන්නේ. I'm telling you, it is since the time duration is identical for both the instance. Let me to take the time duration from here to there as Tp divided by 2. Are you clear with this? It is something like that. Started from here, turn back and come to this point. Minus A plus A. Here minus A plus A. If you take the 5 seconds from here to there, it takes again 5 seconds to travel from here. Method to 5 seconds, method to 5 seconds. That's what the linear motion we learn. The total time TP from here to there, it is TP by 2. If you take the time here as T equals 0, then T equal TQ by 2. They want us to calculate those two things. Obtain expression for the TP and TQ. Right. Final velocity 0 here. We can apply for you want to write the question number C part 1. For P, we can apply V equals U plus AT. Final velocity 0. Initially we have V1. minus acceleration into time, TP. TP divided by 2. 0 V1, or else we can take V1 equal acceleration. Acceleration we can apply it from here. ඕනනම් F equal ma apply කරලා දාන්න එක ගැටලුවක් නැහැ. මේ වගේ තැනක අපි ඒක කරපු නිසා මම මේ ඔයාලට explain කරනවා. Since you have calculated the acceleration for such kind of a particle, you can straight take that EQ divided by n. Here EQ divided by m into TP divided by 2. So the TP equal 2m V1 divided by EQ. Similarly, look at how I am doing the question. Similarly, TQ equal 2m V2 divided by E into Q. Only the difference is what? V2. Velocity. Identical objects. Only the difference is velocity. Right? When the intensity, I think everyone's okay, ne? When the intensity of the electric field E is equal to a certain value E naught, both particles P and Q which had entered the electric field at different time due to the different initial velocities at x equals 0 leave the electric field at x equals L simultaneously. Write down an expression related to E naught to other relevant parameters given above. Look at here what they mention. It's a very important question actually. You should understand from the basis that මෙතනදී objects දෙකම එකම time එකේ enter වෙන්නේ. මෙයාලා මෙහෙම time එකේ enter වෙනවා. මෙන්න මෙතෙන්ට යනවා මෙයා, මෙතෙන්ට යනවා මෙයා. එතකොට මෙයා මෙතෙන්ට එනකොට මෙයාත් මෙතෙන්ට ඇවිල්ලායි කියලා ඔය කියන්නේ. හැබැයි මෙයාලා enter වෙන්නේ එකම time එකේද? It is not that. එහෙම නෙමෙයි උතන කියන්නේ. If you measure the t equals 0 here, start with the t equals 0. When it comes to this point, both are not at the same time. This one is less than that value because V1 is greater than V2. But remember, according to the question, when it go back, the time duration is same. T, this is T. T equal T. So in my case, how to do this question? How to do this question? One question is clear there. That මෙතන electric field එකට enter වෙනකොට එකම වෙලාවට නෙමෙයි enter වෙන්නේ. හැබැයි electric field එකට ගිහිලා මෙයා වැඩි distance එකක් ගිහිලා return වෙනවා. මෙයා අඩු distance එකක් ගිහිලා return වෙන නිසා එයාලා දෙන්නට එකම වෙලාවක එන්න පුළුවන්. මම මේක මෙහෙම explain කරන්නම්. හයියෙන් දුවන මිනිහෙක් ඉන්නවා. එයා start කරනවා journey එකක්. එයා journey එකක් start කරලා මෙන්න මෙතෙන්ට එනවා. හිමීට දුවන මිනිහෙක් ඉන්නවා. එයා start කරලා මෙතෙන්ට එනවා. මෙයාලා දෙන්නම එකම වෙලාවෙ එළියට එන්නේ. වෙන්න පුළුවන්ද බැයිද? Is it possible or not? It is possible. Why we are saying that as possible thing? Because it travel at the high speed than that. This is also possible because this distance is very less compared with that. So both can leave the electric field at the same time. So these are some critical points that you want to understand. Right. With that in our mind, let's go to the question number 2. For P, the total time for P total time equal, total time is what? I will write like this. Total time spent for P is equal total time spent for Q. Started from a certain velocity, travel up to this point, return back, travel up to this, return back up to that. Total time spent for P equal total time spent for Q. From here to there, what is the time? Distance we know, speed we know, the time, S equal ut. What is the value? S equal ut means time equal S divided by u. P, it is L divided by V1 plus total time spent for P from here to there, P by 2, TP by 2, then up to that TP. It is equal to L divided by V2 TQ. Check whether you got my point. මෙතනින් start කරලා මෙතෙන්ට ගිහිල්ලා මෙතෙන්ට time එක started from x equals 0, come to this point, එකම line එකේ එන්නේ, turn back, come to this point, turn back. This is for the P and this is for the Q. These are possible things. From here to there it is TP, from here to there it is TQ. මෙතන time එක අපි හොයාගත්තේ කොහොමද? length divided by the velocity. Very simple. Okay then. Right. Now, according to the question, what they want, write down an expression for the E0 to other relevant parameters given above. E0. So when it is E0, that could happen. According to the question, when the electric field is equal to a certain value of E0, that could happen. Huh? So now the electric field is E0. L divided by V1 plus TP. TP 2mV1 divided by E0 into Q equal L divided by V2 TQ. It is 2mV2 divided by E0 into Q. L divided by V1 minus L divided by V2 equal 2m. I will take the other way because I know that definitely V1 is greater than V2. 2m V1 divided by E0 into Q minus 2m V2 divided by E0 into Q equal L divided by V2, L divided by V1. 2m divided by E0 into Q, V1 minus V2, L V2 minus V1, V2 minus V1. 2m, look at here how I am simplifying E0, V1 minus V2, L, V1, V2, V1 minus V2. Look at here, V1 minus V2, V1 minus V2 cancel. 2m E0 into Q equal L divided by V1, V2. So E0 equal 2m V1, V2 divided by Q into L. So this kind of value must be maintained for capital E0. Then you can get that answer. Write down an expression for relating E0 to other parameters given. Actually, even though I simplify up to this level, this is accepted. That is enough, right? Mammika simplify kalata, it is not required. No need to go beyond that, right? Even though I simplified, they just want the expression, not the final answer. Mammika simplify kala for you to get an idea, but it's not required. Up to this level is enough. V2 minus V1, V2 minus V1. Yeah, V2 minus V1. We don't have V2 minus V1. We have V1 minus V2. We have V2 minus V1. It is V1 and it is V2. This is V1, this is V2, not V2 minus V1. Right, let me just start question number 38. Question number 38. Just read the question. Question number 38 in your tutorial. Letters, numbers, images, etc. printed by a certain computer printers consist of a large number of very small circular dots just touching one another. The number of such dots printed per unit length is normally used to express the quality of printers. So if you have a number of dots per unit length, if it is very large, that tells us very quality printing. Or dots gana adu වෙනකොට ඒකේ quality ගතිය අඩු වෙනවා. Dots ගාන වැඩි වෙන තරමට quality print එකක් තමයි තියෙනවා. zoom කරලා ගත්තත් even you can see that. Right, resolution is very large. The number of such dots printed per unit length is normally used to express the quality of the printer. Simplified diagram of a system which is illustrate only the relevant parts of an ink delivering process of such printer is given in figure number 1. Use the dimension shown in the figure 1 in answering the question whenever necessary. As in the figure number 1, the ink droplet gun sends a stream of natural spherical ink droplet towards the paper on which the printer is to be done. And the appropriate movement of the system will give rise to a printing. In order to print letters, numbers, images on the paper, only some of these drops must be allowed to hit the paper, and rest of the droplet must be prevented from reaching the paper. This is done by charging only those droplets that must be prevented from hitting the paper, using an electron gun and deflecting them into a gutter by means of electric field produced by a pair of parallel plates. Okay, I will explain this particular concept first. මම මේක ඉස්සෙල්ලාම explain කරන්න මොකද්ද මේකේ වෙන්නේ කියලා කියන්න. Right. Let's say before proceeding to anything, I just highlight what it happened here. හිතන්න මේ paper එකට සම්පූර්ණයෙන්ම ink එක වදිනවා. black ink එක තමයි වදින්නේ. I can't show everything, but think that every point you get a black. You get any letter. You can see any letter here. Can you see any letter? The totally black. The white paper is now totally black with dots. It is, you can't see anything. You can see only the black color one, nothing else. But if you manage to send only the relevant only to the relevant position, you can see, let's say we send only these points. We send only these points. What kind of a letter is that? Looks like what? It is R. Yes, it is R. If you put more dots on these particular lines, you can see that exact the R, which is a quality thing. You have to place more dots along the line, then only it is connected. Quality print එකක් කියන්නේ මේ dots ගොඩාක් connect කරලා ගත්ත එකක්. ඒතරොට දැන් තේරෙන්න ඕන සමහර dots අපිට යවන්න ඕන print එකෙන්, සමහර dots අපිට මේ white paper එකට යවන්න ඕනේ. සමහර dots කියන්නේ print එක දන්නේ නැහැ, යා continuously supply කරනවා ink එක. ink droplet continuously යවනවා. ඒතකොට මොකක් හරි mechanism එකක් තියෙන්න ඕනේ ළමයි. Samahara dots විතරක්, only the certain dots are sent to the paper, but the other droplet must be removed from the paper. ඒකට තමයි electrostatic concept එක ඕන වෙන්නේ. I will explain that. This is the paper. Right. I will help you to get an idea. This is the ink droplet gun. It is continuously send the ink from this gun. Continuously send. Let's say I want it to paste on this paper. This is the paper, this is the gutter, and this is parallel plate, and it is the electron beam. I'm not doing anything. Let's say I'm sending another droplet, ink droplet. I need to, this is the electric field. Let's say this is for the time being, let's say it is positively charged thing, it is negatively charged thing. So there's an electric field in between those two. Let's say when a droplet is released at this point, you send electron gun. Actually, this is capable of sending electron. මෙතන droplet එකක් ink droplet එකක් එනකොට මෙතනින් electron එකක් ගිහිල්ලා මෙයාත් එක්ක touch වෙනවා. ඒතර මෙයාගේ electron ගොඩක් combine වෙලා මේක charge particle එකක් බවට convert වෙනවා. Now it is a charge particle. Now when it is travel through this parallel plate, we know that there must be a deflection. There's a deflection along this line, and it is never come to the paper. Instead of that, it has come to the gutter. Right? Are you okay with that? Can you understand this point? Methanic electron release karnawa, methanic drop එක ink එක drop ink droplet release කරනවා. ඒතර මෙයා electron එක combine වෙලා යනකොට charge particle එකක් තමයි යන්නේ. We know that when a charge particle travel through electric field, it change its direction. So it is collected to the gutter. There's a question. So that means electron gun is used to prevent forming a dot on the A4 sheet. Yes, exactly. Yes, that's true. Electron gun is used to prevent forming a dot on the A4 sheet. Yes. So I told you, if I want to make R, I should remove it. Is continuously sending the ink. That is duty. But we should know that we should manage which drop I should send, which drop I shouldn't send. That is developed by a microprocessor. We are not discussing microprocessor here. අපි microprocessor එකක් දාලා discuss කරනවා මොන ink එකටද වා මේ electron beam එක යවන්න ඕනේ. එතකොට ඒ electron beam එක අර droplet එකත් එක්ක combine වෙලා දැන් යවන්නේ charge particle එකක් විදියට. Right? Anything to ask before come to the question? So need to understand the question, the application first. නිකන් කටපාඩම් කරන්න එපා, තේරෙන්නේ නැහැ කිසිම දෙයක්. ඔයා මේක තේරුම් ගත්තොත් ඔයාට ඊළඟ එක පුළුවන්. අන්න එහෙමයි මේ වැඩේ වෙන්නේ. හුඟක් ළමයි හිතන් ඉන්නවා equations ටිකක් දැනගත්තාම අනිත් ටික දැනගත්තාම you can do that කියලා. This gravity on the no, actually within this question you will realize the gravity part also there, you realize it is negligible. It is negligible. We will come to that in detail. I want you to understand the application. Shall I move to the question now? Simple A. Assume that each spherical droplet emitted from an ink droplet gun has a diameter D, and each droplet produces a circular dot whose diameter is 25% larger than D when it strikes the paper. That is possible. Then හිතන්න spherical you have a spherical droplet like this, spherical droplet like that. If you strike on the paper, what will happen? Spread. It is spread. Now it is increased by 25%. Now it is 1.25 diameter. In it is air, it is D. When it drop on the paper, it is spread. Because of that, it is 1.25 D. That is clear. That is correct. Find the value D must have for the printer to be able to print 200 dots per centimeter. So that tells us what? Within 1 centimeter, you have 200 dots. You have 200 dots. Let's say this is 1.25 diameter. 1.25 diameter. I'm answering for the part A, part 1. 1.25 diameter, 1.25 D into 200 must be equivalent to 1 centimeter. So D equal how much? 1.25 into 200. D equal, can one of you tell me the value? 250, ne? Can one of you tell me the value? 4 10 to the power minus 5 meter. 4 10 to the power minus 5 meter. Yeah, in terms of that, yeah, that's correct. 4 10 to the power minus 3 centimeter, or else 4 10 to the power minus 5 meter. Always keep the answer in terms of SI base. 4 10 to the power minus 5 meter. Right. Right there, a diameter of a drop. Diameter, simple A, part 1. Diameter of a dot on the paper equal diameter on the drop. Diameter of a dot on the paper equal diameter on the dot. Diameter of a dot on the paper equal, we have 200. 1 centimeter has to be divided by 200. Therefore, equal 1 centimeter divided by 200. Can you come to that? 1.25 equal 1 divided by 200 centimeter. It is 4 10 to the power minus 3 centimeter. It is 4 10 to the power minus 5 meter. Right. Part 2. Ink droplet gun shoots droplet horizontally towards the paper with a velocity of 20 meters per second. Ink droplet gun shoots droplet horizontally towards the paper with a velocity of 20 meters per second. Calculate the vertical displacement of a natural droplet due to the gravity when it hits the paper, which is placed vertically 4 millimeter away from the ink droplet gun. Show that this deflection is much smaller than the diameter of a dot printed on the paper. Look at it. That is what I think Rashmika asked me that question. So I think you are okay with that now. Let me to explain. The method distance is given as 4 millimeter. Yeah, it is 4 millimeter. It is 4 millimeter. It is 4 millimeter. If you release a droplet at that point with a certain velocity, it is given as 20 ms minus 1. Let's say that 20 ms minus 1. So definitely it go like a projectile. It go like a projectile. This is the horizontal line, and go like a projectile. Let's say this height as h, this depth as h. This is 4 millimeter. It is h. So you have to find the h value. This is 4 millimeter. We can apply location A here, location B. From A to B, it's now projectile. From A to B, S equal UT. S equal UT. S how much? 4 millimeter. 10 to the power minus 3 millimeter. Velocity 20. The time. Time equal 4 divided by 20. 10 to the power minus 3 second. This is the time duration. From A to B, it takes this much of time. Now we can apply from A to B downward direction. S equal UT plus half rate squared. S, it is h. Initial velocity 0 because horizontally you project it. Half acceleration 10 t squared. We can simplify further. T squared 4 10 to the power minus 3 divided by 20 squared. H equal 5 400 16 10 to the power minus 6. This is we can simplify further. Method simplify karanna tibba. Okay, fine. This is 4. No, we simplify further. That's complicated. Okay, t equal 5 10 to the power minus 3. Now simplify. 5 10 to the power or the 10 to the power 3, 10 to the power minus 3 squared. 5 squared 10 to the power minus 6. It's cancelled. 0.2 10 to the power minus 6 meter. 2 10 to the power minus 5 meter. What was the diameter we obtained? What was the diameter we obtained? Diameter 4 10 to the power minus 5 meter. It is not that, it is 2 10 to the power minus 7. So 2 10 to the power minus 7. You can say that H is less than D, because D equal what? D equal, what was the value you calculated earlier? It is 4 10 to the power minus 5 meter. Now H, it is what? 2 10 to the power minus 7 meter. Since H is very small compared with D, H can be neglected. For example, if a droplet is strike on this plate, අපිට මෙතෙන්ට තමයි යාට දාන්න තිබ්බේ. හැබැයි මෙතෙන්ට ආවේ. ඒක කවන්නේ කව වෙනවා සියල්ලම එක drop එකකින් හේතුව H කියන එක මේක drop එක හරිම පොඩි. H is very small. 2 10 to the power minus 7 meter means very, very small amount. In terms of millimeter, you can't even imagine. It's very small number. Just multiplied by 10 to the power 3, you get 2 10 to the power minus 4 millimeter. It's a very small number. Just write under that, H is smaller than the diameter of a dot. H is smaller than the diameter of a dot. Therefore, effect of gravity on the position, of the droplet, is negligible. All right, I think we are okay, right? Number B, let's move to number B. Each droplet which has to be deflected into a gutter is given a charge of 1.6 10 to the power minus 10 coulomb by allowing a very narrow beam of electrons from the electron gun to strike the droplet under suitable condition. So suitable condition means from a microprocessor only we send the electron beam. We send it when it is required. Suitable condition. A potential difference of 50 volt is applied between the parallel plates. 50 volt. Right. $50 volt, only 50 volt is given. So now it is charged by each droplet which has to be deflected into a gutter is given charge of. So we have a droplet, it is given charge. Let's say now Q, the Q charge is given as minus 1.6 10 to the power minus 10 coulomb. මෙතනින් electron beam එකක් යවනවා. එතකොට මෙයා ඒක පිරිලා charge වෙලා තමයි යන්නේ. By allowing a very narrow beam of electrons from electric gun to strike the droplet under suitable condition, a potential difference of 50 volts is applied between the parallel plate. If the droplet move across the electron beam, as shown in the figure number 2, right? Figure number 2, find the time required for a droplet to pass the electron beam. Find the time required for the electron. Find the time required for a droplet to pass the electron beam. So now you have a droplet like this, right? You have a droplet like this. මෙන්න මේ වගේ තැනකින් electron so you send the electron beam, you start to send the electron beam here, right? You send the electron beam here. Now it is moving with a certain velocity. So when it comes to this point, still we are getting the electrons. At this point, start with electron beam continuously send. So at this point, start this droplet start to get the electrons. It get up to this level. Up to this level, you can see that diameter only affected. Diameter would affected only, right? Find the time. So let's say the velocity is given. The velocity of that is given earlier. It was given as 20 meters per second. It traveled 20 meters per second. 20 meters per second. Let's say started at t equals 0. Now the t equal t. T equal t. That's what we want to find. I just do the question. After that, I will explain. S equal ut we can apply. S equal, it is the diameter d, which is which was calculated earlier 4.10 to the power 5, 4 into 10 to the power minus 5, velocity 20, the time t equal 4 divided by 20, 10 to the power minus 5, which is 0.2 into 10 to the power minus 5, t equal to 10 to the power minus 6 second. This much of time spent for to load with the electrons. Check whether you got my point. 2 10 to the power minus 6 second or else 2 microsecond. මෙන්න මේ line එකේ තමයි electron එක එන්නේ. මේ line එකේ continuously electrons release කරනවා electron ගන්න එකේ. එතකොට මෙයා මෙහෙම ගිහිල්ලා මේක pass වෙනකම් electron absorb කරනවානේ. මෙතෙන්දි තමයි electron absorb කරන එක නවතින්නේ. Okay. Now tell me what is the time duration? How to find the time duration? You can get it from S equal ut. But what is this? It is the diameter of that. Is it clear for you all? It's a very important and interesting question. මම හිතනවා ඔයාලත් මේකට කැමති ඇති කියලා. මේක හරිම interesting question එකක්. Even I remember the last week one of the students asking me application of this particular subject. Everywhere we have that applications. Assuming that all the electrons which strike the droplet are uniformly distributed over the surface of the droplet, calculate the electric current due to the emitted electrons from the electron gun during the charging process. So I just skip that part because it is linked with the current electricity. I just skip that part. My current electricity sum I skip karanna. ඒක ගැන හිතන්න එපා. When the time comes you will learn. ඒක ඇති දෙයක් නැහැ. time එකත් එක divide කරන්න තියෙන්නේ. I will move to part C. Find the electric field intensity between the parallel plates. between the parallel plates. Now you know the voltage. It is a positively charged thing. It is a positively charged thing. You know the voltage. What is the voltage between those two locations? Let's say voltage. It is given. Voltage is given as 50. Voltage is given as 50. Find the electric field intensity. C, part 1. Electric field intensity equal voltage divided by the D. Actually, I told you electric field intensity is given by the voltage divided by the D. Voltage given as 50. D distance is given as 0.5 millimeter 10 to the power minus 3. According to this, it is 500 divided by 500 into 10 to the power minus 3. It is 1 10 to the power minus 1, or else 0.1 Newton per coulomb. It is 0.1 Newton per coulomb. Is that the answer? Or else we get different answer. No, it's wrong. 100 into plus 3. 1 10 to the power 5 Newton per coulomb. This is the electric field intensity. Next point. What must be the direction of the electric field? Very important question. If you want, this is a plus charge now. It is plus charge with the travel with the velocity v. If you want to take into a gutter like this, what is the sign of this plate? Whatever charge is there? I mean top plate. Is it positively charged one or negatively charged one? ඔයාට මෙතෙන්ට තමයි කලෙක්ට් කරගන්න ඕනේ. එතන positively charge එකක්ද මේක negatively charge එකක්ද? Think and tell me. Think and tell me. If it is negatively charged one, is it negatively charged one? This is a positive one. If it is a negatively charged one, think about what happened. If it is, think about that and tell me the answer. I need your exact answer. දැන් මෙයා යන්න ඉන්නේ මේ track එකේ. But I need it to collect into a gutter. I'm sorry. Yeah, I'm sorry. Negatively charged one. No, it is negatively charged. I'm sorry. Yeah, negatively charged one. The droplet is negatively charged one. You are correct. It is a negatively charged one. Yes, that's correct. Now tell me, do we need to think about what kind of charge it should be then? Positive one or negative one? It is negative one. I think everyone is agree with that. It's a negative one. If it is negative, this must be positive. So that tells us the electric field is upward. You should know that it is positively charged plate downward. Then only you can attract to the gutter. So you can write there, direction of the electric field is upward. Direction of the electric field is vertically upward. Direction of the electric field is vertically upward. Direction of the electric field is vertically upward. Right. Number D, the last part of this. The mass of a charged droplet is given as 4 10 to the power minus 11 kg. find the angle that the gutter must make with the horizontal direction so that charged droplet travels straight into a gutter as shown in the diagram. Right. What is our requirement? If this one travel with this direction, no problem, it can be collected. So at this point, at the last point, you have two velocities. One is v, another one is vx, another one is vy. One is vy, another one is vx and vy. Let's say the angle here is theta. So according to that, the cutter is placed with the angle theta. So if it is theta, this must be theta. So let's find what is the value of theta. That's all. Let's say location A dash, location B dash. This is 1 millimeter, 1 millimeter. And also this is the total one is 0.5 millimeter. 0.5 millimeter. Since it is a negatively charged plate and positively charged plate, you are getting the force downward direction. Let's say F. Q charge also there. We can apply S equal UT. No need to find Vx because already we know that value. What is the value of Vx? What's the value of Vx, Lamai? Can you tell me? Yeah, it is 20. Good. It is 20. 20 ms minus 1. It is 20. Okay. 20. One node naha. But we have to find the Vy. We will try to find the time duration from where to where. A dash to B dash. S equal UT we can apply with the idea to find the time. S, it is 1 millimeter, 10 to the power minus 3. Velocity 20, the time. T equal 20 divided by 10 to the power minus 3 second. T equal 0.05, 10 to the power minus 3 second. So we got the time. From A to B, A dash to B dash, S equal UT plus half AT squared, we can apply. S, it is 0.5 millimeter, need to be divided by 2. Initially, we don't have horizontal velocity. No, we have to go with a different equation. V equals U plus AT, because our idea is to find the Vy in a downward direction. Vy equal, started from 0 velocity vertically. Acceleration, time, it is t, time we know, but we have to find the acceleration, downward direction, F equal ma. It is EQ, mass into acceleration, EQ divided by m. That's from there we can get Vy, acceleration EQ divided by m into t. What's the value of t? T equal, we can substitute that value. Capital E we got that value. It is 50 divided by 0.5 ne? 0.5. We obtained that value earlier. Capital E, it was calculated as 10 to the power 5. 10 to the power 5 Q charge. It is 1.6. 10 to the power minus 10 times 5 10 to the power minus 5 divided by the mass. Mass also given. It was given as 4 10 to the power minus 11. 1.6 into 5 means 8. 8 means 2. 2 10 to the power. Cancel 10. 20 ms minus 1. Is that the answer? Was that the answer you got? Yes. Okay, good. Few students got the answer. Right. Now we realize we have horizontally 20 ms minus 1, vertically 20 ms minus 1. So the angle you can calculate as theta. What kind of a value it should be then? Tan theta equal this value divided by that. 20 divided by 20, it is 1. So theta equal how much there? What is the value of that angle of the gutter? What is the value of theta? It is 45. Exactly, it is 45 degrees. 45 degrees. අපි 45 degrees වලින් ඔය gutter එක තිබ්බොතින් අපිට පුළුවන් ඒවා collect කරගන්න. බලන්න කොච්චර interesting question එකක්ද කියලා. ඉතින් මේක තනියම කරන්න බෑ අත්‍තර. ටික කාලයක් යනවා මේ level එකට යන්න. තනියම කරා නම් හොඳයි, but it takes certain time. What is important is to understand the question once I explain. ඔයාට තනියම කරන්නත් questions තියෙනවා. ඒකට පුළුවන් වෙනවා. Do you have anything to ask regarding this question? The one is asking me, so is it better to do those questions than mechanics essay as final exam? So when you look at the mechanics question and these questions are much simple. If you look at the past paper question, you will realize there's a reason behind that, because these questions are not tried by many of the students. Most of the students, they skip those questions. ඒක නිසාම යාලා ලේසි කරනවා. දැන් mechanics වගේ subject එකක් ගත්තොත් මේක හැම සර් කෙනෙක්ම හොඳටම කරනවා. ළමයින්ට අපහසු වෙනම කාරණයක්. නමුත් හැම සර් කෙනෙක්ම ඒකේ පුළුවන් question ප්‍රමාණයක් කරලා සෑහෙන කාලයක් කරන් කරනවා. එතකොට ඒකේ දෙන්න පුළුවන් variation එකක් ගොඩක් වැඩි, because you know that there are several sections starting from conservation of linear momentum, power, energy work, Newton's laws, even rotational motion, circular motion, fluid static, fluid dynamics. They can change many up to many extent. It can go up to several extent, but for these type of questions difficult. It's all lazy. Right, shall we touch question number 39 also? පොඩ්ඩක් අපි try එකක් දෙමු 39 question එකත් යම් ප්‍රමාණයකට හරි කරන්න. Question number 39. ඉතින් මේ questions තුන තේරුණා කියලා කියන්නේ මේක යටතේ ඔයා lesson එක තේරුම් ගත්තා කියන එක තමයි. ඉතින් අපිට next week එකේ පුළුවන් මේකේ ඉතුරු lesson එක Gauss law එක පටන් ගන්න. Let us start question number 39. Two metal plates A and B kept parallel to each other in a vacuum are connected to a voltage source as shown in the figure. A molecule ion of mass M and charge plus Q starting from rest from a plate A is accelerated toward the metal plate B under the influence of the voltage we maintain between the plates. So actually you don't have much idea about the voltages, but you know that when you apply a voltage, that's an electric field. This is what a harima theruma israhat ena oru wenna epa. Number A. Happen to write anything there? No, the data is already given, and no need to do anything. Question number part A. Write down expression for the kinetic energy gained by ion when it reached to the plate B. Right. Question number 39. We have the distance as d naught. The particle is released at this point plus q charge. The voltage is given. This is a positive plate. It is connected with the positive terminal. So it's a positive plate. It is a negative plate. Electric field intensity V divided by D. We know that. V divided by D. So the kinetic energy, to find the kinetic energy, we know that the kinetic energy equal for the part A, part 1, kinetic energy equal the work done. Work done by the electrostatic force. Electrostatic force. ඉතින් මේක හදන්න ක්‍රම ගොඩක් තියෙනවා. You can apply the linear motion equation and calculate the velocity, or else we know there's a force on this charge and force multiplied by displacement is the work done. That is indicated as the kinetic energy. Are you okay with that? Right. The work done equal the force F into D, D naught here. The kinetic energy equal F into D naught. What is F naught? It is equal to EQ into D naught. What is E here? It is V divided by D naught. Voltage divided by D naught. E here. Q into D naught. D naught cancel. QV. The kinetic energy is given by QE product. The මේවා ඉස්සරහට තවත් ඔයා හරියටම තේරුම් ගන්නවා. Under the voltages, we will discuss that. Derive an expression for the velocity acquired by the ion when it reached the plate B. So how to find that velocity? Let's say the velocity when it reached the negative plate as V. Number 2. Velocity at the negative plate. Velocity at the negative plate is D. V half mv squared equal q into V. Don't confuse with, I'll take V dash and confuse with V1 kilogram. Let's say V1. Otherwise, you confuse with the voltage. Make a couple of V1 squared equal 2q into V divided by M. V1 equal to Q into V divided by M root. This is the velocity. Number 3. The one is asking me why the system is connected to the earth. Actually, these questions, these things I can't explain right now. There are reasons for that connection. When the time comes, I will explain. මේ lesson එකේ මේක තියෙනවා. හැබැයි මේ lesson එකේ මේක තියෙන voltages වලදී මම මේක කියන්නම්. If D naught is the distance between the plates, derive an expression for the time taken by the molecular ion to reach the plate B. Right, they want us to calculate the time. We can apply V squared. No, what is the equation? They want us to calculate the time next. V equals U plus 80. we can apply V equals U plus AT. Check whether you got the idea. V1 we calculated initial rest, acceleration into time. V1 2q v divided by m root of that. Acceleration, it is a into t. Let's say number 1. We can apply F equal ma horizontally to find the acceleration. E into q ma, a equal eq divided by m from number 1. 2qv divided by m equal acceleration eq divided by m into t. Now you can simplify this. T equal m square root m, and m you can I will write like this: m squared eq squared 2qv divided by m. What I did there, I take this square and put inside the square root. T equal cancel, q cancel, 1q cancel. So 2mv divided by e squared into q. E squared into q. What is e squared? It can also be replaced with that. E squared, v squared divided by d naught squared. V squared divided by d naught squared is here into q. T equal 2mv into q. E. T equal capital E means v divided by d naught, 2mv divided by q. Check whether you got my point. Is it confused for you all? Yes, you can further simplify this v and this v cancel. You can cancel this v and that v. Finally, you end up with an answer d naught 2m divided by vq. This kind of answer is there for the time. But I'm with the product confused. First, I apply v equals u plus at for this particle, charge particle. There, I realized the velocity equal acceleration into time. Velocity I found earlier. After that, acceleration I need. So I apply f equal ma. With that, I can substitute the values. Here simplified, here simplified. Instead of capital E, we can apply v over d naught. Capital E can copy them. So we have to replace with that. V over d naught. V over d naught, we substitute this way. So finally, we end up with the answer d naught into 2m divided by vq. Right. Next point. Suppose the metal plate B is now replaced with a metal wire mesh so that ion moving through the region AB could enter field free region and move towards an ion detector capital D. It has to be capital D, capital D. Placed at a distance S from the wire mesh B as in the figure number 2. Can you please make that correction? Suppose the metal plate B is now replaced with the metal wire mesh so that the ion moving through the region AB could enter a field free region and move towards an ion detector D placed at a distance S from the wire mesh B as in the figure number 2. Consider two molecular ion 1 and 2, masses M and charge plus Q, suddenly so I didn't cut voltages and velocities. Actually, velocity I replaced with the voltage. May V kila kena velocity eka. V1 kila kena velocity eka. V kila kena voltage eka. Mang cut kala na eka. Put check kala baana. Consider the two molecules ion 1 and 2 of mass M and charge plus Q suddenly being formed at time t equals 0 at a distance d1 and d2 from the wire mesh B as in the figure. If they start from rest and move towards B under the electric field, derive an expression for the time t1 and t2 taken by ion 1 and 2 to reach the mesh B and indicate which ion reached the mesh first. Right. Okay. So there's a wire mesh. Wire mesh there's a room to travel across it. Here, the particle 1 is having a distance d1 from there. There's another particle d2. The distance is d2. Distance is d2. So both particles released from t equals 0, t equals 0, t equal t1, it is come to this point, t equal t2, it is come to that location. They want us to calculate T1 and T2. The both charges are plus Q charges. Within that system, there's electric field. Electric field direction is, as I marked, it's a positive plate and it is a negative plate anyway. So the T1 and T2 we have to find separately. We can apply S equal UT plus half AT squared for particle number 1. For particle 1, we can apply S equal UT plus half AT squared. S, it is D1, initial rest, half acceleration T1 squared. T1 equal to D1 divided by A. 2D1 divided by A. 2D1 divided by A. T1 squared equal that value. T1 squared equal to D1 divided by A. So A කියන එක EQ divided by M. ඒක අපි ඉස්සෙල්ලා තේරුම් ගත්තා V over D naught M into Q කියලා. E means V over D naught Q divided by M. For this acceleration is common for both sections, both particles. Just substitute here 2D1 divided by A. That means VQ divided by D naught M. D naught M. T1 equal to D1 D naught M divided by VQ root. This is the time T1. 2M D1 D naught divided by VQ. Similarly, T2 we can write මෙහෙම ආවට පස්සේ ඒ විදිහටම ලියන්න පුළුවන්. Similarly T2 equal to D2 D naught M divided by VQ. Anything to ask? Any one of you? So don't give up, try your best to understand. Don't give up, try කරන්න කොහමද තේරුම් ගන්න. So we got T1 and T2 separately. And indicate which ion reached the mesh first. Which ion? According to this answers, which ion reached the mesh first? Which one? Can you tell me which ion reached the mesh first? Yes, ion number 2. The reason is the time duration is small. D1 is greater than D2. Just write under that. Based on the results obtained, based on the result obtained, based on the result obtained, based on the result obtained, T2 is less than T1. T2 is less than T1. T2 is less than T1. So that means ion number 2, that means ion number 2 reach the mesh first. Reach the mesh first. Ion number 2 reach the mesh first. right. දැන් අපි මෙතෙන්දි කළේ ළමයි දැන් මෙතන ඉඳලා මෙතෙන්ට ඉක්වේෂන් එක ඇප්ලයි කළේ ඒක ගැටලුවක් නෑ s = ut + half-a t². මෙතන ඉඳලා මෙතෙන්ට තමයි ඇප්ලයි කළේ. හැබැයි අපි දන්නවා මේකේ ඇක්සලරේෂන් එක කෝකද කොච්චරද කියලා. we have to apply f = ma. අපි ඒක ඉස්සෙල්ලා කළා. ඒකෙන් තමයි මෙතෙන්ද අපි ඇක්සලරේෂන් එකට ඇප්ලයි කළේ. f = eq = ma. But what is E? It is V divided by D naught into Q MA. So A equal V Q divided by D naught into M. ඕක තමයි substitute කළේ acceleration එකට. ඒකෙන් තමයි මේ equations ගත්තේ. වෙන දෙයක් නෑ ඒකේ. Next they ask us to calculate the velocities. We can apply for the number 2. Let's say the velocity of this particle. Let's say the velocity of this particle as v1 and this is v2. v1 and v2. v1 v squared equal u for the particle number 1. For the particle number 1, v squared equal u squared plus 2as. v squared, it is v1 squared started from rest to acceleration. Acceleration equal v into d1. v1 squared equal, what was the acceleration we calculated earlier? It is what? vq divided by d naught m. d naught m into d1. v1 equal 2vq d1 divided by d naught m square root of that. Square root of that. Check whether you got the idea. 2qv d1 divided by d naught m. Similarly, v2 equal 2v. Only the difference is d2 divided by d naught m. Root of that. So once we calculate for one thing, the similar pattern is there, so we can substitute for the second particle. The next one, they asked us to highlight the higher velocity when reached B. Which ion has the higher velocity? Which ion has the higher velocity? Looks like what? D1, ne? V1. V1 is higher than V2. Reason is D1 is greater than D2. Just write under that. Since D1 is greater than D2, since D1 is greater than D2, V1, sorry, the speed of the particle number 1, ion number 1, the speed of the particle, you can go with the V1, no problem. Since D1 is greater than D2, V1 is greater than V2. V1 is greater than V2. Right, last part. Derive an expression for expression in terms of T1, T2, V1 and V2 for the suitable value for the distance S at which the detector D has to be placed so that it detects both ion 1 and 2 at the same time. Let's say we place the detector at this point. It is the detector. This is the distance S. What happened? Both would detect at the same time. At t equals t, it comes to this point. T equal t, this comes to that point. The velocity here is v1. The velocity of that is v2. මේක ලං වුණොතින් සමහරවිට මෙයා ඉස්සෙල්ලා එනවා මෙයා පස්සේ එනවා. හැබැයි මේක ටිකක් ඈත් කරොතින් මෙයා ඉස්සෙල්ලා දෙන්නම එක වෙලාවට හම්බ වෙනවා අපිට කියන එකයි ඔක මීන් කරන්නේ. Earlier we obtained, I think earlier we obtained that T2 is less than T1. T2 is less than T1 means this object comes out from the field earlier than this. Example, for example, let's say t equals 3 seconds, it comes out from the field. But here it is t equals 5 seconds, it comes. But the velocity is larger. මෙයා වැඩි ස්පීඩ් එකකින් එළියට එන්නේ. මෙයා අඩු ස්පීඩ් එකකින් උනාට අඩු ටයිම් එක දිලට ආවේ. ඒකට මෙයා වැඩි දුරක් ගිහිල්ලා වැඩි ඩිස්ටන්ස් එකක් ගිහිල්ලා. But finally they would come to some location, same point. So that is what it means. Can you understand the question? Are you clear with this, Lamai? Not clear or clear? Right, ne? T equals 3 seconds, for example, right? T equals 3 seconds, ion number 2 comes out from the field and it travels with the velocity v2. At t equals 5 seconds, even it takes another 2 seconds more than that t1. T1 takes another more 2 seconds. So 5 seconds, after 5 seconds only it comes out from the field. ඒතර මෙයා වැඩි ඩිස්ටන්ස් එකක් ගිහිල්ලා. හැබැයි මෙයාගේ ස්පීඩ් එක වැඩි නිසා කොහෙද හරි මීට් වෙනවා. We have to keep the detector at that distance. So they want us to calculate, they want us to develop the relation. So what is the relation? We know the time started from here t1, time started from here t2. So we can say the total time elapsed for both sections, both particles are the same. Right? Since both ions number 1 and 2 identify at the same time, since both, I repeat it here, since both ions number 1 and number 2 identify at the same time by the detector D, we can say T1 plus, from here they travel with this constant velocity, so the time duration must be s divided by v1 must be equal to t2 s divided by v2. That is the answer. So they want us to calculate the value for the s. We simplify that. T1 minus T2 equal s v2 minus v1. T1 minus T2 v1 v2 v1 minus v2 s equal v1 v2 t1 minus t2 divided by v1 minus v2. This must be your answer.